Hello my dear students, this is Akash HD. Welcome to the ASD Physics classes. Hope so you all are doing really great. So students, in this video we are going to solve the question from the chapter Electromagnetic Induction. Even some part will overlap with the alternating current, okay, because both the chapters question used to come from both the chapters combinedly, okay. So let's go through the question. The question is, an EMF is generated by an AC generator having 100 turns, coil of a loop area 1 meter square. Now the coil rotates at a speed of 1 revolution per second and placed in a uniform magnetic field of how much? 0.05 Tesla, perpendicular to the axis of rotation of the coil. Okay, now the maximum value of EMF is how much here? Now, so this is a formula based question, but first we'll note down here whatever things are given here. Okay, so first it is given here how many turns are there? 100 turns are there. I will write here the value of n is 100. After that, area is how much given here? The area is given here. I will write here the A, 1 meter square. Next one, the coil rotates at a speed of how much here? See again, 1 revolution per second. So remember that here it is given here omega it is given here. What is given here? Remember that here 1 revolution per second. That means we can write here 1 RPS. But RPS is not the SI unit of the omega. What is that? The SI unit of the omega is radian per second. So for that, what we have to do here, to convert this RPS into radian per second, we have to multiply with the 2 pi. Okay. So when I will do here 1 into 2 pi, it will become here radian per second. RPS to radian per second, we have to multiply with 2 pi, and RPM to radian per second, we have to multiply with 2 pi by 60. Remember that. Okay. Now after that, what is given here? See, the magnetic field, it is given here how much? Magnetic field B equal to 0.05 Tesla. And one more important thing is what? That is the coil is perpendicular to the axis of rotation. So remember that here in AC generator, what happens? The coil rotates. And here which thing is involved? The area vector is involved. Okay. So remember that here I will just tell you the basic here. Let's take for example, this is one coil. Rotating coil is this. And here what is this? The magnetic field is going like this, for example. See here. So in this situation, magnetic field in this direction, you can see the area is perpendicular to the magnetic field direction. We can tell magnetic field along x direction and this coil in a YZ plane. Okay, but in this kind of situation, remember that here the concept of area vector comes. What comes here? The concept of area vector comes, and the area vector is always perpendicular to the area. If the area in a YZ plane, then area vector is along x-axis. So you can see very well the area of the coil is perpendicular to the magnetic field, but area vector is along the direction of the magnetic field. Theta how much here? Remember that here the theta is the 0 degree. Okay. Now after that, they are asking here the maximum value of the EMF. So remember that here the formula is, general formula I will tell you, E equal to E naught sine omega t. Now this formula you have to use, E equal to E naught sine omega t, and for the maximum value, this is the maximum value, E naught. Okay. So here what will happen that here maximum value is given here. Remember that E naught equal to NBA omega. How much here? Maximum value NBA omega. Okay. Now all the things are given. We will just put the values and all, and we'll get here the answer. Okay. So let me write here as maximum value, or this is called peak value also, NBA omega. Now, n how much given? N, see here 100. N is given here 100. Okay. So n is 100. Magnetic field how much here? 0.05. Area is given 1 meter square. Omega how much here? Not 1 RPS. We have to write 2 pi. Okay. So this is the 2 pi. So now what will happen that here 100 into 0.05 means 5 into 2 pi. That means it will become how much here? It will become here 10 pi. And what is the value of the pi? Pi means 3.14. When you will multiply with 10, it will come here 31.4 volt. What is coming? 31.4 volt. Is it, students? So let's check here the option. 31.4 volt. Correct option is here option B. Kindly see very well, students. So I hope so students, this basic you have understood very well. And one more thing I will tell you here, the flux is used to be given by phi naught into cos omega t, because question used to come from here. And remember that here in this situation, EMF E naught sin omega t, flux phi equal to phi naught cos omega t. And here what happens that here cos function always ahead of sin function by 90 degree. Okay, so we can tell here question used to come phi is leading by 90 degree from E. Okay, this also kindly remember that. Okay students, so I hope so this question you have understood very well. Keep studying, keep growing.